Welcome again, folks, to part 2 of our video tutorial series on IXP Manager and root servers. In the first part, what we looked at was just an introduction to root servers and why they're important at internet exchange points. Now, in this part 2, what I want to do is I want to look at configuring root servers with IXP Manager. So earlier on today, I actually had an online webinar with APNIC on securing and automating root servers with IXP Manager. And as part of building the infrastructure to support that webinar, I'll be using a lot of the virtual machines and stuff to create these more longer sessions where we can take our time with some of the detail. So, what do we need to create a root server? So there's some essential elements that we need. We need an AS number. And it's very important that this AS number be dedicated to the root server. It shouldn't be the AS number that you might otherwise have for your Internet Exchange Points management IP addresses or anything else. It should be an AS number that's dedicated to the root server. If you're running more than one internet peering LAN at your exchange, you can use the same AS number for those multiple peering LANs, but the AS should be dedicated for root server use only. Ideally, you'll request a 16-bit AS number. It's much less important these days than it was historically, but there still are a number of networks that have a 16-bit AS and don't support large BGP communities, for example. So just to make it easy on them to use the standard prefix, the standard community tags, the 16-bit tags, try and request a 16-bit AS number for your root servers. It's still important for a couple of more years, I think. You need an IPv4 and IPv6 address on your peering LAN. You need a router ID. That's usually just going to be your IPv4 peering address, unless you have some specific reason otherwise. You're going to need your BGP software, and we talked about that in the last in part 1. Are you going to support MD5? Yes, you are really at your exchange, because many networks on a shared peering network, on a peering fabric such as an internet exchange point, will require the use of an MD5. You should use large communities, as I discussed in part 1 as well, because enabling large communities has no drawbacks but offers loads of advantages. We'll talk about our PKI in part 5, I think. That'll probably be the last part of the series. And we'll also look at looking glasses in the next part 3. So once you have all the required bits of information, you need to add your router to the IXP Manager. So this is an IXP Manager that I've just set up on a virtual machine here on my desktop. What I want to do is I want to go to routers here on the left. And again, you'll have seen these if you're following around past tutorials. On most pages, you got this documentation link. And when you open that up in a new tab, what you're going to find is over part 2 and part 3, we will really be following an awful lot of the content in this documentation. So if you're struggling to keep up with what I'm doing, just use this documentation to help you out. So I'm going to add a router. Now again, I'm going to remind you all that on our forums there's this help button, and that will break it down into a huge amount of detail about what's required in each box. And I'm going to leave that open for now. And in fact, what I'm also going to do, I'm just going to see if I can make this just a little bit bigger for us all. Okay, the handle. So in our fictitious exchange here, we're going to have 2 root servers for resiliency, root server 1 and root server 2, and they'll have protocols IPv4 and IPv6. So I'm going to call it RS1-IPv4. Now, at INEX, for example, we run 3 exchanges, INEX LAN 1 and INEX LAN 2 in Dublin, and INEX Cork. So we'd often differentiate it like that, or like that, for example. Sorry, like this. So whatever suits you. If it's one exchange, you really just need RS1-IPv4. We covered VLANs in a past session, so we've got a peering VLAN here. We're going to do IPv4 first. Now, I mentioned that IXP Manager will allow you to create configurations for a number of different types of routers, root collectors, AS112, and so on. In this case, we're looking at root server, so our type is going to be root server. You can give it a really long name if you like. I'm just going to go with RS1-IPv4 here and RS1-IPv4 here. Now, we're into the IP addressing. So I'm going to use the same router ID as my peering IP address. And I'm going to pick just a private AS number here for demonstration purposes. So I'm using the documentation IPv4 prefix here, and I'm using the documentation AS prefix here. So these aren't real routable addresses or AS numbers. Now we get into a software version, operating system, or AS version. Now this is essentially free text. So whatever you select here has no actual bearing on the configuration. But organizations like the IX Federation and EuroIX will pull this information through the IX member export schema, the JSON schema. And this information will be exposed in that. And it's useful for those organizations to try and build a profile of what IX is, what software they're using, what versions are they deploying, and so on. Now we're into our management host. So this is this would be used in a few places, such as when we're generating Nagios configurations later on, and so, some other bits and pieces that might be required. And of course, yourself can automate configuration out of IXP Manager. So on my platform here, this is the local management address. An API. We're going to come back. We're going to do an API later, but I'm just going to set it up now as bird's eye, and I'm going to set my endpoint just as I'm here. And I'll come back to this again later and I'll explain those in a bit more detail as well as this. Okay, so you don't need to worry about that for now. Quite often at an IX, you might require new members to connect to a quarantine root collector, for example, and ticking that box would just mark this as a quarantine root collector rather than a production root collector. We are going to enable large BGP communities. So as I said, there is no reason not to do this when you're running Bird version 2. It won't break anything on your customer side. We're going to leave this off for now. We're not ready to talk about RPKI yet. RFC 1997 pass-through. So this is where there's a number of well-known communities. Let me see if I can pop this open. Yeah, so there's a number of well-known communities such as no export and no advertise. It has been undefined what a root server should do when it sees these tags. The consensus has gone to pass them through without interfering with them. So this is unchecked by default because when we released this, it would have been a break and change. So we have left it unchecked, but you should turn it on as you're building a new root server. One of the reasons it was left off is because it would reset BGP sessions on Bird. So that's why it wasn't on by default. Skip MD5. It's worded that way because it's trying to indicate that you shouldn't. You shouldn't do this unless you really want to. And then the last option is the template. So IXP Manager, you can skin templates in IXP Manager, allowing you to actually change the configuration that we do by default. It's important to note that at INEX, we don't do that. We use the default configuration as we include it in IXP Manager. So there's no reason that you should need to change it, but the facility is there for you to do it. We've also got root collector configs, AS112 configs for Bird 2, and then the same for Bird version 1. Okay, so I'm going to create that root server. I'm just going to make this back to normal size. So here's my root server created. Give me 1 second here now. I will just get the next piece of what I need to do. Okay. So back to my slides, I think. Right, okay. So what I've done, as I said, is I've now added the root server to IXP Manager. What we can do now is we can actually view configuration. So IXP Manager, you need an API key for this. So open your My Account and under API keys, it's dark reminder, treat your API key as a password, which is why mine are hidden by default. I can show them if I like. So there's the key. That's the key I'm actually going to use in this. If I wanted to add another key, I could do that here, no problem. And there's a new key added, and it shows it to me here just a one time only. If I refresh the page, you can see it's hidden again. I would need to put in my password. So get rid of that other key, and I'm going to keep that key. So I have this key. What I want to do now is I want to pull the configuration for my root server. And again, I just want to remind you that what I'm doing here is documented on this page, right? So I'm not, even though it might look like I'm cutting and pasting stuff in here, it's straight out of the documentation. So let's have a look at my command line here. Okay, just go on to this guy here. So I'm just going to paste in. So I've got my key, which is the API key from IXP Manager. Now on my own system here, the URL for IXP Manager is http://192.168.140.210. And you can see that yourself right here. That's it right there. Okay. And then a handle. I told you the handle was important when you're creating your router. The handle is how we reference it in API calls and places like that. So with that information, I can now use curl. Right, you can see here, curl. I'm passing in my API key in a header. I'm calling the URL /rs1-IPv4. I'm going to pipe the output into less. And there it is, quick as that. There's my root server configuration. Now, what I can also do, I don't need to do that on the command line. I can click on this button right here and see that configuration directly. So just make this a little bit bigger. This is the boilerplate. So if we scroll right down to the bottom, I've got no root server clients defined because I have specifically not enabled any members as yet to be root server clients, because I just wanted to show you the boilerplate config. So what we have is some time format definitions, ISO long, and that's for the looking glass. The looking glass expects times to be in that format. We got some logging. Now we've got, straight out of our configuration, our AS number and our IP address. Right, so we just set those variables here. So anywhere you see later on the configuration root server ASN referenced, it's replaced with 65501. Same for the root server address. Got a router ID, which we just said is the same as the root server address. You'll see why we use this later, but these are essentially a list of bogons for IPv4. And remember, we set the config to IPv4. If this was IPv6, we'd have an IPv6 list of marshals. We define a bunch of large communities. And what I'm going to do is I'm going to come back and look at these later when we're looking at an actual client configuration. We have the standard IX community filter. And again, I'm going to come back and look at this in a little while. We've no ORPKI because it was not enabled for the router. We filter known transit networks. So I'm going to come back again and talk about this in a little while. And then lastly, we just have a template configuration for our root server client. So our actual BGP configurations are just going to extend that later. So we have a local AS as the root server AS number, source address as the root server address. Remember, they were defined above. We're setting this up as an ORAS. We're telling Bird that this is a root server client, which tells Bird to handle it in certain ways, and particularly, for example, not to insert the root server's own AS number in the AS paths. The IPv4, we're going to replace that later as well. So, no clients. Let's turn on a client. So I'll go back to normal size. I'm going to jump to just one or two test networks I added. So root server client turned on. And now if I pop back to here, if I refresh this page, look what's after happening. Right. So I've got a whole bunch of new stuff for this client. And we're going to step through this in a moment on the slide deck. I just want to highlight one or two things. I told you that every single network that appears with the root server gets its own routing table. And that's what we're creating here. We're creating this routing table for this network AS1213. We have an import filter. So all the routes that this network sends us is going to come through this filter here. And we'll go through that in detail in a minute. We have an export filter. And I told you already that all we do in the export filter is that we strip out any community tags that we might have added ourselves. And if you recall, and you'll see again in a second, there's two protocols. There's the pipe, which pipes between the master and the member's own routing table. And then we've got the actual BGP client configuration. So I'm going to go through that in a bit more detail on the slide deck now. So this was a reminder that as we step through the configuration, we have a BGP configuration that provides an IP address for AS112 and the AS number. And that sets up the BGP session between the member's network and our router. All of the prefixes that are imported end up in AS112's own routing table, and we saw that table being created. And then we have a pipe to put those into the master routing table. So that's the structure that we're always looking at here. So straight out of what we were just looking at from IXP Manager, this is the client configuration. So some specific things that jump out at us here. First of all, we got the neighbor IP address. That is AS1213's configured IP address on IXP Manager. Okay, that's come straight out of IXP Manager for HEANet. We've got an import limit, and again, that's come out of IXP Manager. In IXP Manager, when you add a new member to your exchange, you can set a global prefix limit, and then on a per VLAN interface basis, so anywhere where you set their IP address, you can also set import limit. Whichever one is higher is essentially the one that will win. The import limit is, especially as a client of a root server, the IX is going to be sending you routes from lots of networks, and actually not even as a client of a root server, because we're going to hope our root servers are secure. In a bilateral peering session with another member at an exchange, if you're not going to put on prefix ACLs yourself, one of the best things that you can do is put on a prefix limit, and that will set it sufficiently low. So if it's a small network with maybe 5 or 10 routes, set it to 20 or 50. If they ever leak routes, a default free zone leak, that will bring down that session straight away. It's a great safety mechanism, and it's part of the configuration that we do here as well. And it also, in terms of, it also acts as a anti-denial of service. So if a network started to try and shoot us millions of prefixes, once they got to the import limit, the session would be torn down. So we spoke about this, the RFC 1997 well-known community pass-through. That was like the no advertise, no export. So we've turned the interpretation of those communities off so we can just pass them through. There's our MD5. Again, that is configured straight out of IXP Manager. Make this normal size. So here you can see the 100 for the max prefixes, and you can see the the MD5 here. That's their own dedicated routing table. So again, I've told you that every peer gets its own routing table, and this was defined previously in the configuration. Let me just flick back and just remind you about that. So at the top of the client configuration for AS1213, we created their routing table. Okay, and that's saying that any routes that we learn from this session should be imported into this table, and any routes that we want to send this peer should be exported from this table. So now we have an import filter, and this is really the meat, the main element of how IXP Manager secures root servers. So we saw the filter here as a fairly long stanza, and it's not even complete there because we haven't enabled RPKI or IORDB. But let's look at the ones that we have. So there's our filter function. So if we step through each of these tests and just explain what they do. One thing, as most of you probably realize, in IPv4, anything smaller than the /24 is not considered routable in the default free zone. It's too specific, and it would create too many routes in a router's routing table, especially when they're hardware limited on their ASICs. So similarly to your transit provider, our root servers are not going to allow a member to advertise anything smaller, anything more specific than a /24. That is configurable, but the defaults are a /24 for IPv4 and a /48 for IPv6. If the network is too small, if it's within that 25 and 32 for IPv4, you can see here, BGP large community add. We're adding this large community, and this IXP LC filtered prefix length too long. That is in the boilerplate community, and the boilerplate config, and it's one of those things I said I would come back to later. It's this here, okay? So anything that has a root server AS number, in our case 65501, and 1101 ... they are prefixes to be filtered that will not make it from this member's routing table through the pipe to the master table. They'll be stopped in the pipe. So that is why we tag them, but then accept the prefix. We do allow that prefix to come into that member's own routing table, but it will be eventually stopped by the pipe from getting any further. So that's why it may look strange that I'm saying that we're going to block these, but you might see accept. We are accepting them into that member's routing table, but we will not propagate them through the pipe later on. Now we want to avoid Martians. So again, that was a little bit further up here. That's our Martians. So if our prefix matches any of these, for example, if it's a 192.168x.x IP address or prefix, that's the RFC 1918 space, and that's going to be filtered. So anything in this list will be filtered, including the default route. So that will be tagged as filtered because it's a bogon, it's a Martian. So we accept that in. And when we see accept here, what we're telling Bird to do is accept the route into that member's own routing table, stop processing it, and move on to the next prefix. So we don't go any further with that route. We move on to the next route that that client is advertising. Now, is the peer's AS number the same as the first AS number in the prefix or the route that's being advertised to us? This is a belt and braces check. If AS1213 is advertising a prefix to us, then AS1213 should be the first AS number in that prefix's, that route's AS path. All right. If it isn't, something's gone wrong, something's misconfigured, or there's some peering session established that shouldn't be. So we flag that first AS, not peer AS, for filtering, and we move on. Now, BGP next hop hijacking. There was an interesting story from in IX in a very large country where they had a small member that was part of an exchange on the East Coast, and they also had a POP on the West Coast with really expensive backhaul in between. So it cost them a fortune to route their traffic between their two POPs, but they were a member of an exchange at each end. Another member of that exchange happened to be that country's incumbent telecoms network, and they were a member of both exchanges. So our bad network with the two POPs and the really expensive transit in between might have advertised, for example, a /24 over here and a different /24 over here. And what they would do is over here, if they wanted to send traffic over here, what they would do is to all of their other peers, they would advertise this network /24 to all of the peers over here. But instead of taking that traffic in themselves and backhauling it themselves, they set the next hop for that traffic as the incumbent network's IP address. So the incumbent brought that traffic across the country and then passed it back to the network, to the AS, to that network over on the other side. So they hijacked another network to carry their traffic. And that's what we mean by next hop hijacking. So if the from address, the peering address, is not the same as the next hop, the gateway address in the route, then we're going to do some checking. If it is the same, we skip this clause altogether, we move on. It's perfectly normal. You're getting a route and you're told that the next hop to this route is true me. Perfectly normal. So it's only if it's different. So the first thing we have to check is the network that's advertising the route, they may have more than one address at my exchange. For example, at INX, Apple and Limelight, for example, have two connections to INX LAN 1. So they have two different IP addresses. And they could advertise a route from this router, from this IP address, pointing at their other IP address. That's perfectly valid. There's nothing wrong with that. So what we do is we check if the next hop is, while it's not the router that's sending us the route, maybe it's one of their other IP addresses. And that's what we're doing here, a list of all IP addresses. In this case, there's only one, but there may be multiple for a particular network. And if it's in that, we're just going to put an info on that, just because it's a curiosity. So we're just going to highlight it in the looking glass, but we're not going to take any action. It's perfectly valid. On the other hand, if it's somebody else's IP address, if they're trying to do a next hop hijack, maliciously or accidentally, we tag it for filtering, and we move on. Okay. So the filter known transit networks. Now you can see there's no community being added here. That's because we're actually going to, as you'll see in a second, this function takes care of everything. So filter has transit path. So that is this function here. Right. So the set of transit ASs is a set of AS numbers belonging to transit networks who have stated publicly that their AS number should never appear in the AS path of a route advertised over an internet exchange. Right, so if you think about it, these guys are IP transit providers. They don't rely on anybody else for transit typically, so nobody else should be advertising a route with their AS number over the exchange. Right, that should make sense hopefully. So if we see one of these ASs in the AS path, it probably means that it's a route leak or a misconfiguration of some sort. So what we do is we see if any transit ASN is in the route's BGP path. If it is, we tag it for filtering, and we say that this is a transit-free AS number, so that we can figure out later why it's been filtered, and we return true, which means that route is then accepted into the routing table, and we move on. So tags it and returns true. Otherwise, it returns false. So you can see here, if it returns true, we accept it, we move on because a transit AS was in the AS path. If it's false, we just continue on as usual. So our next check, this is very much a belt and braces check. You may remember a couple of years ago, there was a huge internet outage, disrupted many networks when someone injected a route into the default-free zone with more than 256 AS paths, broke an awful lot of software stacks. So this check just makes sure that the BGP AS path length on the prefix isn't more than 64. I can't conceive a reason why you would need more than 64. I think that would just be broken. Never mind 256. So if it's more than 64, we're just going to tag it that the AS path is too long, accept it, and move on. Right? We're not letting that in. We're not going to propagate that on to any other member. We're skipping the RPKI check because we haven't configured it. But what we are doing is we're going to tag the route so that we can see later in the looking glass, this route was accepted, but it was not RPKI checked. And the same for IORDB. This route was accepted, but it was not IORDB checked. And then we finish off with an accept. Okay, so that's our inbound filter. At this stage, any route that we've accepted in either has a tag to be filtered or has some form of informational tag because it's okay. So if we go back to our BGP configuration for the neighbor, we just looked at the import filter here. Let's have a quick look at the export filter for the routes that we send to that neighbor. So you will have seen in the import filter, we kept adding all of these large community tags to the routes. The only thing we need to do before we send a route out to a peer is we need to delete any tag that we added, which is to say any tag, any large community that has the root server ASN, in this case 65501, .star. And same for a standard 16-bit community, anything with the root server ASN, .star. And then we accept, which means advertise the route. So what we were just looking at there on the export filter was as this routing table was sending the route to the peer. I am aware, by the way, sorry, my graphics here are slightly different to the examples. In the examples, I'm using AS1213 as the sample network. In the graphics, I'm using AS112. But in either case, these are just root server clients. So what we saw there was the export where we stripped the tags. Previous to that, we'd seen the import filter, which was the routes coming the other direction. Now what we're going to have a quick look at is this pipe. Okay, so the bridge between the member's own routing table and the master routing table. So this is the pipe configuration. And you can see it's a pipe between table master and the peer's own table. Right? So just as it's shown in the diagram, it's a pipe between the master routing table and the network, the peer's own dedicated routing table. A pipe has an import filter, and you can see it's actually written there. So the import filter is what it imports into the master routing table, and the export filter is what it exports to the member's dedicated routing table. And that direction is defined by what has the table and what has the peer table. And it's written in a language as well that makes it clear. Import filter is what we are exporting to the master table. And then the export filter is what we send from the master table to the member's own routing table. And if you remember in part 1, that was really just about the IXP community filters. In fact, we're going to have a slightly closer look at that here now, maybe. So the export to master, that's this guy here. This is what we are taking from the member's own routing table, which, remember, is a mix of good and bad prefixes, and what we want to send into the master. And what we're saying is that if any route has a tag, root server ASN 1101.star, we're going to reject it. 1101. If you remember from our community definitions, just up here, all of the 1101s were bad. They were to be filtered. Okay, so that's exactly what we're doing here. Anything with 1101, we are rejecting. We're not sending into the master table. Everything else we're accepting. So just the good routes get to the master table. In the opposite direction, the export, or the IX community filter, and I suppose what's important here is that we're passing 1213. So we're telling this function to check this route for export to 1213. So that's our pure ASN there, 1213. So if you remember from part 1, and if you haven't, maybe go back and have a look at it. All of these community tags were about what we want, how we wanted to control routes as they were advertised to different members. So in the example here, let's imagine some makeup client 65503 tagged their prefix root server ASN 101.1213. So you might remember 101 meant prepend my route one time to AS1213. So what we're saying, PRSN 1213 that was passed in by my pipe configuration. There it is, 1213. So if this tag is part of the BGP large communities of the route, then prepend the path with the first ASN. So add 1213, or sorry, add whoever's advertising that route's AS number, so that 1213 gets it prepended. Okay. So as a summary here, and summarizing parts 1 and part 2, in fact, we know what root servers are now, and we know why they're needed. Hopefully we have an understanding of why they need to be secure, of the onus, of the responsibility that's on an internet exchange to make sure that we secure them properly, because of the effect a misconfigured root server could have with a malicious or accidental threat actor. We've seen how IXP Manager generates configuration. We've examined the basic structure of that configuration, and then we've enabled it for a client, and we've examined the client configuration in detail. We've gone through the import rules, the internal tagging of the large communities, informational and filtering tags. We've examined the standard root server communities. We've got a basic understanding, I hope, of bird topology, and we've got a working root server configuration. Okay, so we have that all of those things now from part 1 and part 2. What we're going to look at in part 3 is actually deploying root servers with IXP Manager. So now that we have this configuration, we're going to actually build a root server and show you how you configure that root server using IXP Manager and keep it in sync. Okay, so again, thank you for watching. I keep mentioning the websites, but what's most important, as always, is docs.ixpmanager.org, and that's where you'll find a huge amount of information on this. You'll get me, as usual, at Barrio79 on Twitter, and you can reach out to me in email at barry.o'donovan@inex.ie. Thanks again for watching.